Hello everyone and welcome to the Game Engine programming series where we write a game engine from scratch. Previously, I added an asset registry that keeps track of all assets in the game project. I did this first because the content browser, which I'm going to write in this video, will need this functionality. So today's video is about writing the ViewModel for the content browser. I'll also start working on the WPF control for the user interactions, which will be similar to Windows File Explorer. Let's start by adding a new class for the content browser and inherit from ViewModel base, since this is a ViewModel. Similar to the asset registry, we need a class that holds information about files and directories in the content folder. Because this could be a file or directory, I'm going to call it ContentInfo. I'd rather call it FileInfo, but that one is already taken and I don't want to specify the namespace every time we want to use it. So here we have a constant which holds the width of the icons in Content Browser. Then we have an icon and a small icon. We use those in the same way Windows File Explorer displays the icons as you can see here. We have large icons when we display files in tile view and small icons when we are in list view. Next we have the full path and file name exactly as we did for asset info. In fact, I'd understand if you told me to inherit one from the other. And sure, feel free to do so if you're following along. However, these two classes have rather different usages and should, in my opinion, be distinct. Let's continue by adding a boolean, which is true if this file system object is a directory, followed by the date it was last modified and its file size. The file size is nullable because directories don't have a size. This makes it easier to display the size for files in the content browser view, even if their size is 0, and omit the size for directories altogether. You may have noticed that all of these properties are get-only, and that's right, we set them in the constructor where most of the parameters are optional. The reason for this will become clear later in the video, but here we just assign them to the properties and figure out if this represents a directory or a file. That's it pretty much for the ContentInfo class. For the content browser, I would like to be able to detect changes in the content folder in the same way we did for the asset registry class. Therefore, I'm going to copy the file system watcher and delay event timer and use them here as well. We also need a getOnly property that holds the root path of the project's content folder. Next, we have the collection of all files and folders in the currently selected folder. I'm using an observable collection here because we want to view them in the content browser panel. I already mentioned the selected folder, so let's add it next. Now comes the part where we initialize and gather information. I'll start with the constructor, which gets the content folder path from the project and initializes the content folder property. My convention is to have a directory separator at the end of directory paths, but File System Watcher gives us directory paths without the separator at the end. And that's why I removed it here. When we create a content browser, we start off in the content folder, so selected folder is the same as content folder location. Next, we initialize the read-only collection of content info with the actual observable collection that contains the items. Finally, we initialize the content watcher and refresh timer, which we can again copy and paste from the asset registry class. Now we need to implement the event handlers for file system watcher and delay event timer events. I'll start with onContentModified method. Because we are viewing the contents of a specific folder, we don't care about changes in other folders than the selected folder. So we simply return if the changes are not made in the selected folder, but if there were any changes, then we trigger the refresh timer. When the refresh timer triggers an event, we handle it in our refresh method by updating the folder content collection. To do this, I'm going to write a separate method. Because this could involve opening files to read their information, I'm going to make this an asynchronous method where we can asynchronously call an overload of this function to get the folder content. Please note that I'm not directly changing the underscore folder content collection, because doing that would update some UI elements which have a thread affinity with the UI thread. Changing this collection on a non-UI thread would provide us with a nice set of error messages about everything but the real cause of the problem. So when we have our list of files and folders, we clear the folder content and add the new items one by one. I'm going to write the getFolderContent overload next. This method can be static since it doesn't use any data members from this class. Again, I'll put the code in a try-catch block. Then for each file or folder within this path, we create an instance of ContentInfo and add it to the list. We add the subfolders first and then continue with the asset files if any. I would like to avoid opening all the files in a folder every time we display them. A better way is to cache the information and save it for the next time, and only update that information if there has been a change in any of the files. So I'm going to add a ContentInfo cache, which simply contains a dictionary of file names and their corresponding content info. We can then save this information to our .primal private folder to be reused later. Then whenever we are getting the content of the selected folder, we can first look into this cache and see if the content info for that file is already loaded, so that we don't have to open and read the file. But if the file is not already in the cache, or it's been updated, we need to reload its information. Even then, we first check the asset registry, and if it's not in there either, then we read it using getAssetInfo method. Using this information, we can construct a new content info for this file and add it to the cache, as well as to the list of folder contents. That's all for this method. Of course, we also need to call it whenever the selected folder changes. So here in this properties setter, we can call getFolderContent if we have a valid folder that's not the same as its old value. One thing we need to be careful about is the fact that we are calling this method from different threads. It's called by the refresh timer and in the selected folder property setter, which both execute on the UI thread. However, we are also calling this method asynchronously on a non-UI thread. That means that we could get a data race condition while we are manipulating the items in our ContentInfo cache. To avoid this situation, I'm going to use a lock to synchronize calls to this method. I just add a lock object and lock the for loop here, and that will take care of that problem. Next, we are going to look at the file system watcher. Here we can see that it implements the iDisposable interface. This means that we need to call its dispose method when we are done using it, in order to release it properly. Because C# doesn't have deterministic class destructors, I'm going to make the content browser to implement iDisposable as well, and then get rid of everything in its dispose method. Here I can tell Visual Studio to automatically generate this method for us, and while we are here, I can also save the ContentInfo cache to a file, so we can load it in the constructor if we create any other instances of the content browser, or even the next time that we start the editor. So now we need to implement these two methods that save and load the cache information. To save the cache, we first block the function, since we are going to read the dictionary and we wouldn't want it to change in the meanwhile. Then we create a file stream in a binary writer and write the information that we want for the next time. These are the full path to the file, its last modified date, and its icon. Loading the cache file is pretty much the same, except now we need to read from it. So in the same order, we read each file's full path, its date and icon, and add it to the cache dictionary, but only if the file still exists. And here's the reason why most constructor parameters of ContentInfo are optional. We only set them explicitly when we load the cache. Otherwise, they come from the asset registry or by directly reading the asset file. Alrighty, this is the minimum functionality that we need for our content browser, and now we can use it as the data context in the content browser view. Because we inherit the data context from the parent of this control, which in this case would be the main window with its data context set to the current project, we first set our data context to no. We don't have to do this, but if we don't, we'll get a lot of binding errors, which are not fatal, but obviously we don't want to have any errors at all. Because the location of content folder changes with each project, we need to update the content browser ViewModel when we switch projects. We can attach an event handler to data context changed event of the main window, which will notify us when the project is changed. We also call this event handler to get things going. In the event handler, we dispose of our old data context, if any, and create a new one for the current project. Here we can attach an event handler to our ViewModel to get notified when the selected folder changes. We'll make use of this in a later video. For now, I'll leave it like this. I think we are ready to try and display the files in the content browser now, so let's go to the XAML file and create the controls for it. Let's give it a nice background color so we can see what we are doing. Then I'll add a border on top that will hold some of the controls, similar to Windows File Explorer. I'll use a list view control to display the content info. As you can see here, its item source is bound to the folder content collection. Is text search enabled and text search.text path make it possible to navigate between items by pressing the first few letters of a file name. Here you can see that ContentInfo has a file name property which is used for this functionality. Again, this is similar to Windows File Explorer. Here I'm pressing different letters and you can see the selection bar jumping around. While here, let me also create a folder so we can test if everything is working as intended. Going back to the XAML file, I'm going to define a style for the list view. Of course, I can set the properties directly, but as you will see later, we'll need a style trigger to toggle between tile view and grid view. For now, I only set the background color and border properties. Let's run the editor and see if it does anything. Here you see 3 items that correspond to 2 asset files and 1 folder that I just created. So that looks promising. To properly display each instance of ContentInfo, we need to define a grid view which will tell our list view what columns need to be displayed. The first column displays the file name, so its header is name, and each cell within this column displays an icon and the file name next to it. Again, I'm just mimicking the File Explorer here. Also notice that I'm using the small icon style for this. To easily set a bunch of properties for our icons, I'm going to define 2 styles, one for large and another one for small icons. And to show you what I mean, I have 2 icons for the folder items that I'm going to copy to our resource folder. When adding resource files, don't forget to set their build action to resource in the properties panel. Otherwise, you can't access them at runtime. Here in this small icon style, when we have a directory, we use the small image I just added. Otherwise, the asset files icon will be used. For the large icon style, we use the larger image. This was all for the file name column. The next column displays the date on which the file was last modified. The header and cell templates are straightforward, but I do need to format the date using string format. The last column is for displaying the size. This one is a bit different because I'm going to use a converter on this later to convert the file sizes to a human readable format in terms of bytes, kilobytes, megabytes, and so on. Now we set the view property of our list view to use this grid view. You can already see in the designer that we have the column headers. Let's start the editor to check it out in action. Absolutely unspeakably hideous. But it works, and that's always a good thing. Let me try adding a new asset by creating a plane. Although we get that exception I discussed in the previous video, we do manage to read and register the new asset file. This is where I'd like to leave it for today. The next couple of videos will be blue episodes, where I'll spend some time working on the appearance of this content browser, and by doing so, hopefully make it more pleasing to use. As always, thank you for joining me, and if you'd like to recommend these videos to others, just hit the like and subscribe buttons if you haven't done so already, and YouTube will do the recommendation for you. Thanks again, and I'll see you next time. Thanks for watching. If you like this video, please feel free to like and subscribe. If you join me on Patreon, you'll get access to the code on GitHub, so you don't have to type everything over from the video. Plus there are also other nice goodies and rewards exclusive to my Patreon supporters. Please use the link in the video description to check them out. I hope to see you next time. Until then, take care and happy game engineering!